also we have seen that how we can find the pre-order traversal of some binary search tree, and now we will basically go for next one, that is in order traversal. In case of in order, we have seen that it is basically left child first and then its node, and then node means parent, then the right child. So that means with respect to this part, if you consider only this tree, if you start, obviously I will start from root, and with respect to this root, I have only left child is B and left child, right child is C. If you forget about the other nodes of the tree, then you can say that okay, so according to the in order strategy, it will become B, then A, then C, right? But if you if the other nodes become visible, then you can see that B is not the leaf node. B has its child also. So when you will come here to print this B, at that point B can be considered as the node or a parent of some other child nodes. Now if B is the parent, then you cannot print B before printing its left child, if its left child exists. And we can see that left child of B exists, that is D. So that means before B, I must print this D, because if you consider only this 3 as a part of the tree, with respect to this 3, the order between B, D and E should be D first, then B and then E. Right? So that means this B cannot be, we cannot start with this B. This B part should be something like D, then B, then E. And you see D is basically a leaf node. So if you, when you will come to print D, you will find that there is no left child, there is no even right child. So basically it will become null, node null. Null doesn't have any existence, so just omit this null, only the node will left, that means the D will left. So there is no way to divide or enlarge the part of D, and B is the root node, at least with respect to B, D and E. But there is a way to enlarge this E part, because E is not a leaf node. E has its left child and no right child. So if you consider only this part, you can say that if I apply the in order strategy with respect to this part only, it will become H, E, then null. And null means nothing, you can omit that. So that means H, E. So you can enlarge this part as H, E. Right? So that means ultimately the uh, the order become something like D, B, then H, then E. So this whole thing, then only you can write A. Now see, a very interesting point here is that means how we can, you cannot actually do it in this way, because if the tree is very large, in that case it will be pretty difficult to enlarge each and every nodes individually. But if you visually, if you want to do it from a tree given, we can start from this A. Always remember, you cannot stop till the left is not null. You have to go extreme left node first, and you have to start printing from that point. In this particular tree, the extreme node is D, extreme left node is D, right? This H is not extreme left node because H came somewhere towards right, but D is basically left child of each and every left nodes. So it's extreme left. So that's why D will be printed first. Then I will come here. Since it is in order, that's why left, then right. I mean, then its parent, that is B. Then it should be right. But if the right child has a left child again, I have to go left first. That means I have to go left till I will not get null. That's why after D, I have printed B, and then again I came here and print H, then E. So that means my order, let's erase this part to, so ultimately the order become D, then B, then H, then E, and then A. So basically you see that this is the whole left subtree of the actual tree rooted by A. So your left is completed, as we have seen with respect to the original tree. Left is completed, then node, that is the parent, that is the root A, and then I'll go for right. So if you go for right, we have to apply the same technique again. So if you go for right, I'll get C, but C don't have any left child. So basically, if you print the tree with respect to C as a root, so it will become left null, then C, then something in the right side. So at least one thing is sure, if there is no left child, the node can be printed directly. And then I can forward towards right. So I can print F, but I cannot here. Why? Because F has its left child. So without printing its left child, you cannot print the node. That means after C, you must check whether F is left, right child of C contain a left child or not. If it's contain left child, come to the left first. Even if I consider there is one more left child of G, for example, some J, left child of G was J, that means J should be printed first, then G, then F. Anyway, so yeah, we don't have any left child of G here. That means after C, G will be printed, and then only H can be possible to print. And if it is done, then I can go for I, and I can see that I is again the basically a leaf node, so I can print I. G, I'm sorry, it's not H, it should be F, and then I. So you see, this set of values are actually the right child, right part with respect to the original tree rooted as node. So this is my node, right? It's with respect to the original tree. So this LNR is maintained not only with respect to the original tree but also with respect to the other subtrees. If you check this part, this is my node and this is my left subtree and this is my right subtree, right? Similarly, if you consider C, for example, C don't have any left subtree, that's why left side of C contain directly N. There is nothing between N and C, but C has a right child only. That's why the right subtree is present. So recursively, this LNR relationship is true for each and every non-leaf nodes. Now we will go for the post order traversal. And we have seen in the post order, first left child, then its right child, then its node. That is the root. So that means with respect to the first tree, if you consider that first B will be printed, then its right child C will be printed, then only A is possible to print A. So it is very sure that this actual root of the tree will be printed last. For example, if you check over here, actual root was printed first in case of pre-order. Actual root was in between left and right subtree of the actual tree. But here you will see that A will be at the last. At least this is sure. So if you start, if we write that B, A and C, if we write that B, A and C, with respect to this, I'm sorry, it's not B, A and C. It should be B, C and A. But you know B is not a leaf node. So B has something to enlarge. C has also something to enlarge. Something. Then we can write A. Now if you stand on B, you will see B has a left child D and right subtree EH. So you must do left and right first, then only you can print B. That means if you consider only for B part, it will become D left side, then the right side. Right side means E, but you cannot print E because E have some childs. So first child has to be printed, then its parent. So you cannot print E. You have to print H first and then null, then E. But null you cannot, you don't need to write. So basically with respect to this two part, first H then E. So that means after D we will have an H and then E. So this is my left, these two are my right. Now we can print the node B. So this B is enlarged in this way. Similarly with respect to C, you see C don't have any left child. So basically nothing to print in the left of C. But C has some right child. So you should print F first before printing C. But you cannot print F right now because F has its child. Both childs, G and I. So you must print G and I first, then you can only print F. So you should print G and I first and then only you can print F. So if these are possible, I mean there is nothing in the left side. So basically it was null. Then after printing this F, then you can print this C. So you see it is your left of C which was null, it is the right of C and this is the node. Something like C will be enlarged in this way and then A. So if you just connect these two, I will get the post order of actual tree. Right. So I can write the post order, I mean I can easily predict what will be the post order. That will become D H E B and in this side we will have G. Null is not, I mean not needed to write. G I F C and then I can write A. So you see, this is your left, this is your right, and this is the node. So this LNR is maintained in this way. And not only for these two, I hope you have understood that how the LNR is maintained for its left and right subtree also. So this is a way by which basically we can traverse a single tree in multiple way.